What's up everybody? In this video, we are going to learn how to pulse an LED. To do this, we will program the Arduino to send an analog output to make the LED fade in and out. Start off by logging into Tinkercad using your course username. Select Circuits in the left-hand menu. You will see our LED analog write circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-Pulse. Our circuit is complete. We need to adjust the code to get the LED to pulse. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is LED-Pulse and the description is a sketch where we will pulse an LED using an analog output. Declare the variables. We will create two new variables, LED brightness and LED increment. Type int LED brightness equals 0, semicolon, and int LED increment equals 5, semicolon. The LED brightness will hold the brightness of the LED. The LED increment variable will hold a variable that will determine how fast the LED brightness variable will increment in each loop. In the loop function, delete the lines of code from the previous sketch, keeping the delay function. Type analog write open bracket LED pin, comma, LED brightness, close bracket, semicolon. Next, add the line LED brightness equals LED brightness plus LED increment, semicolon. Each time the loop function executes, it will add our LED increment value to the LED brightness, so it will increase by a rate of 5 with each loop. Add a serial.println open bracket LED brightness close bracket semicolon so we can debug the brightness sent to the LED. Change the delay to 50. Click Start Simulation and ensure you have the serial monitor open. You should see the LED light up and the values incrementing by 5. Something interesting happens when the value goes over 255. The light gets dim and starts the process over again. If we look at the serial monitor, however, the values being sent to the analog write function are over 255. If you let the program run, the numbers will keep incrementing, but the LED will continue to perform the same behavior. So why is this happening? This has to do with how computers understand numbers. At the base level, computers understand zeros and ones. A number for the PWM is represented as 8-bit binary. The diagram shows how this is represented. In 8-bit binary, the highest number is 255. The next bit would be added to the left and is 256. The Arduino ignores anything over the 8 bits. So while the number in the serial monitor might show up higher than 255, it effectively starts counting back at 0. The behavior of the LED isn't exactly what we wanted to achieve. When the LED reaches a brightness of 255, we want to start decreasing the brightness by the LED increment variable, or 5. To do this, we will change the value of the LED increment to a negative value when the brightness reaches 255, and a positive value when it reaches 0. We can use a conditional statement to check the value of the LED brightness variable and change the increment. Type if open bracket LED brightness is less than or equal to 0, vertical slash LED brightness is greater than or equal to 255, close bracket, open curly brace, close curly brace. Inside the curly braces, add the line LED increment equals negative LED increment, semicolon. So what's going on here? Our if statement checks for two conditions of the LED brightness variable. First, we want to know if the value of the variable is less than or equal to 0. Second, it will check if the variable is greater than or equal to 255. You will see two vertical bars in between the comparisons. The bars mean OR in programming. So if either one of these conditions is true, execute the code inside the curly braces. If the condition is false, it will not execute the code. Click Start Simulation, and you will see the LED increases the brightness and the serial monitor prints the brightness value. When the value goes above 255, the increment becomes negative and it counts down until it reaches 0. Then, the increment changes to positive and starts again. At the end of this video, you should have a better understanding of how to pulse an LED using a conditional statement.